special cases of electron configuration where it doesn't quite follow what is expected. So if we look at the first instance, we have vanadium, and of course it fills the 4s sublevel first, and then it starts filling the 3d. Now it fills the 3d with each orbital. It does not double the orbitals because of Hund's rule. Now with chromium, what you would expect is that it will have the 4s filled, and then it will just have 4 unpaired electrons occupying 4 orbitals. Now this is what it is expected, but rather what happens is this electron becomes unpaired in the 4s, and then it suddenly goes like this. So now instead of having one paired orbital in the 4s sublevel and having 4 unpaired orbitals in the 3d sublevel, chromium instead has one unpaired 4s sublevel and then a filled 3d sublevel just with unpaired electrons. This is also reflected with copper. So what you would expect is, again, you have the 4s filled, and then as you fill it up, you expect the copper to look something similar to like this. So it fills 4 orbitals completely and has one unpaired orbital in the 3D. Rather, again, the 4s becomes unpaired and it completely fills the 3D sublevel with paired electrons. So this is the special instances. Otherwise, the order of electrons are as expected from Hund's rule, but in this specific instance with chromium and copper, which are the two elements you have to remember, it is a bit different. So if you look at the electronic notation instead, the electronic notation for chromium, we'll just start at the 4s part. Instead of being 4s to 3d4, it is actually 3d5 4s1. The same with copper. Instead of being 4s2 3d8, it instead, or 3d9, it instead becomes 4s1 3d10.